So here we are in the TI calculator screen, and we have our data in our L1, 95, 9695. I'm just checking it real quick, make sure I have the right numbers. And then L2, you have your data after the effect. Okay, so notice how I went over to L3. I'm going up to L3. I'm going to hit enter, and I'm going to do L1 minus L2. It's going to subtract for me. So second number one minus second number two. It's dark up here. It was blinking when I hit enter to make sure it stayed up there. I put in a formula to tell the calculator to subtract those for me. So that's what I'm going to do. And then L1 minus L2, I'm going to hit enter, and this subtracts all of my numbers for me. Okay, so let me switch over to Excel. So here we are in Excel, and I have my column A with my labels, and I'm going to put in my data. Thought I had it in already, but I don't. Oop, 96, 95, 95, 99, 87, 104, 105, 94. And then my average after. I didn't put the whole entire name of it, but you can. Okay. So in this column, I normally write what I'm putting in. So you could do x1 minus x2. As long as you don't have that formula in there, it won't calculate. So now I want to put my formula. I want to put x1 minus x2. So my B minus my C. So B2 minus C2. And then I'm going to make sure it's a plus sign. I'm going to drag it down to do my differences. So if you want to put D equals here, let me put D equals here so you know what that is. So D equals x1 minus x2. Now for Excel, you're going to need an extra column. So I'm going ahead and put this extra column in here now, and then we're going to calculate it a little bit later. Okay, so I'm just doing it all at once. So in E, I'm going to put D minus mean. D minus mean, which is our D bar, but I can't really put D bar in there. So D minus mean. So we have to find the mean here in Excel. I'm going to go ahead and find the mean. So I like to label these so I know what I'm looking at. This is the mean. The mean is the sum of our differences divided by n. So I'm going to do the sum of my differences So sum of the differences divided by n. I'm looking at the pairs divided by n. I'm going to write this formula on the side so you can see what that was. So you'll know where I got that from. That's important because I don't want to use this cell for my mean up here. I don't want to use that cell for my mean up there. So I just want my difference minus my mean. So I want my difference minus 1.625. I don't want to put this cell because once I drag it down, it's going to change that cell, and I don't want it to change that cell. I just want it to find my differences for me. So this is D2, the difference, minus the mean. Okay, we're going to use that a little later. All right, so now I have everything set up in the technology. I have my D column in L3 and my D column in Excel. In Excel, we have that extra column, call that E, and we did our D minus mean. We'll put that in. So you didn't have that for the calculator, just for Excel. All right, so let's get our testing done. So we looked at n equals 8, right here. But population was normally distributed, so we're good with that part. Now we need to identify our claim. So the claim is that the people who play golf can improve or decrease their average scores by taking lessons from another coach. So make sure that you can see this. So in golf, increasing your score means that it's going to your score is going to actually decrease. So they're looking to see if the first score is greater than the second, because we're looking to see if the score went down. The claim is that the first score is greater than the second. So let me put that down to make sure it makes sense. So first score is greater than second. So when we're looking at our claim, we're looking at what is affected. So how is the first score compared to the second? How is the first score or first data entry compared to the second? So our first score should be greater. So that means that our hypothesized mean is greater than 0. So our first score, should it be greater or should it be less? It should be greater, because in golf, improved scores means decrease. So our first score should be greater. Okay. The opposite of that would be less than or equal to 0. So we're looking at how are things going. What happened? Did it improve, or did it increase, or did it decrease? In this case, we want to say that the scores actually decreased. So our first score should have been our first score. We're going to see if for the claim, is it actually greater? Second score, did it decrease? So it's our first score. Is it greater? We're looking at what happened first. Is it larger or is it smaller? So again, we're looking at the first set of data. It should be greater. That's what they're saying. The data should be greater with the first score. All right, let's identify level of significance. 0.10. Our DF is going to be 8 minus 1, which is 7. 8 minus 1, which is 7. We are looking at running that t-test. We're going to need a t-naught to compare with our t-test again, or you can use your p-value, but they're going to ask you for t, so you might as well go ahead and run that t-test, find that t-naught. So according to our HA, we have a right tail test. So we're doing 1 minus inverse t. For t, there is no left, right, center. So everybody does the same thing, inverse t. I like to use my formula sheet for this. You can use your calculator, but I like my formula sheet. So there's our IDF of 7. Then this is a one tail test, 0.10. So 1.415 is our cutoff. So any t greater than 1.415 will reject. I like to draw, so if you want to draw your graph real quick, let me just draw it. This is our rejection region. There's our cutoff for T naught. Any T that falls in here will reject. If it falls outside of here, this is a fail to reject. So fail to reject HO, this is our region. So now we need to run the t-test. Now we need to run a t-test. So for the calculator, we're going to put in our data, and then we're going to get our information for the t-test. We're going to hit data because we have data, and then we're going to put in our information. So let me get my calculator. There we go. It looks better. I'm going to go stat, over the test, my t-test, data. This is our hypothesized mean of 0. Our list, it's going to be L3, so second number 3. Second number 3. Sorry, I have it down low so you can see it without the glare. Second number 3. My HA, I need to make sure it matches. I'm going to get calculate. Uh-oh. Let me make sure. I know I ran the test on the computer earlier. Oh yeah, I didn't put it in my calculator. L1 minus L2. Switching from screens. All right, so you all probably got yours. Let me get back to mine. Test, t-test. There we go. All right, so our T is equal to 0.993. Our P is equal to 0.1768. They may ask you for your standard deviation. If they do, it is listed here as well. So our P is high, it's going to fly. That's over 0.10. And then our T is not greater than 1.415. It's like right here. So we failed to reject HO. Let me switch over to Excel. Okay, if you wanted to, this is for Excel. If you wanted to find your formulas using, the manual way, if you wanted to find your answers using the formula using the manual way, then this D minus mean column would be good for you. But if you are just trying to find your answer in Excel, you're going to click on data analysis. And scroll down. There should be a t-test for paired two sample means. T-test for paired two sample means. I'm going to hit OK. Make sure that you change your cells, because wherever you had it last, it's going to put it there. It's going to go and find it there. So variable range was the 1 for the second. That's my variable range for that one. Hypothesize mean difference 0. 0.1 is my alpha. And then my output range, I'm going to put it where it is fine. And hit OK. So notice with your mean, it doesn't give you the mean for both data sets. And that's why this mean, don't rely on it, because it takes the mean of each of those. But I do see my DF of 7. I do see my T-stat. And then I do see my p-value for one tail here as well. So you have your T-stat, your p-value for one tail. For standard deviation, you will need to, if you have to, if they ask you for standard deviation, I'm not sure if they do or not from your homework, but for standard deviation, so I'm doing this with one hand again. Standard deviation is the sum of your D minus your mean squared divided by n minus 1. So let's do that. The sum of the D minus mean squared, you're going to take that caret button to the second power and divide by 7. Actually, I think I need to put an extra parentheses around this because all of this is actually under a square root. Let me put my square root in first. Maybe that might help. So square root, the sum of all that. All right, so to get the standard deviation, we need to look at the formula. The formula is the sum of the square root of the sum of d minus the mean squared divided by n minus 1. I should have written it on this form, but the square root of the sum of d minus d squared, which is this, d minus the mean squared, n minus 1. So the easiest way to do standard deviation is not to square it from here, but to actually create a new column with the squared. So this is d minus mean, which is the d bar squared. So just to square this column, so this is equal, square the column. So this is just the e2 squared. Bring this down. Now I'm going to come back and do my square root of the sum of d minus d2 divided by n minus 1. So square root the sum, and this is for those people again who using Excel. So square root of the sum of the squares divided by 7. Again, you don't want to put n minus 1 in here. You actually want to put that one number, because if you don't, it will give you an error. And so that's how you find the standard deviation when you have Excel and you're using the two paired sample or the dependent sample. So I'm going to run over that one more time. So you have your x1, x2 column, your d minus mean column. You want to square it, square these. This is just this squared, making sure it's all positive. Then you want to, let me use this formula, copy this formula. Of the sum of the squares. These are my squares. Sum of squares divided by n minus 1. And that's how you find it in Excel. All right, coming back to the problem now. So we found t-test in the calculator. In Excel, let me write down these steps. We did the data analysis. And we used the t-test paired to sample mean. Sample means. So you'll know where to go when you're using the Excel. We went over to how to find T and P that's given in your data analysis, and then we went over how to find your standard deviation. let me write that formula down here. For those who have Excel, so you'll know what I was just referring to. So it's the sum of the square root of the sum of d minus our mean squared divided by n minus 1. That was the formula we used to get our standard deviation. Column D was the distances. We found the mean by actually calculating it at 1.625. We squared this and put that in column F. So this was column E, this was column F, squaring it, and then we found that standard deviation in Excel. All right, so how do we make this conclusion? We said that we failed to reject because the T was not greater than our T naught. Our P was higher than our level of significance, so we let it fly. So we failed to reject HO. Failed to reject HO means that HO was true. HA was false. So support is our wording. We could not support what they were saying. There is not enough evidence at the 10% level of significance to support the claim our mean was greater than 0. All right, this is a long video, so I'm going to cut this video short, and then I'm going to make the next example its own video.